This video is for section 6.4. Our objectives in this video are to divide a polynomial by a monomial and use long division to divide by a polynomial containing more than one term. So we're going to start by looking at the quotient rule. This is back on page 71 from one of the sections that we did not do of the textbook. So quotient rule, similar to the product rule that we talked about back in section 5.2, but quotient rule is when we have the same base, we have exponents, and we have two variables raised to a power that are divided. So for example, b to the 7 over b to the 3. We looked at this with power rule. What we did is we wrote this out. We're going to do the same thing here. So b to the 7th means that I have b multiplied by itself 7 times. And b to the 3rd means that I have b multiplied by itself 3 times. So what's going to happen here if I write this out is that I'm going to be able to cancel out one factor of b from the top and bottom. I can cancel out one factor of b from the top and bottom here, one factor of b from the top and bottom here, one factor of b from the top and bottom here. And what that's going to leave me with is just 4 b's on the top, or in other words, b to the 4th. Now I can see how I can get that from my exponents over here of 7 and 3. I can subtract the bottom exponent from the top exponent. And the reason that happens is that for each exponent on the bottom, you can take, or for each variable on the bottom, you can take away one variable on the top. And so since you can take away this many b's, 3 b's, I'm going to subtract the exponents. So I can write that in a formula form. This is b to the m over b to the n. There's nothing special about 7 and 3. It works with any whole numbers. If I'm dividing, I can subtract exponents. And of course, it only works if you have the same letter, so I can't combine different letters, different variables this way. It would have to be the same variable. Then I can write this in words. So if I'm dividing two monomials, we divide the coefficients, and subtract the exponents. And so just like with multiplication, I have different operations here depending on which numbers I'm working with. For the coefficients, I'm dividing them. For the exponents, I'm subtracting them. And it's important to keep in mind what you're doing. So we're going to look next at some examples that are in the text before we do example 1. This is on page 439. So I have this first example, 25x to the 12th over 5x to the 4th. So what I'm going to do is I'm going to divide coefficients, so 25 over 5, and then x, I'm going to subtract the power, so that'll be 12 minus 4. Now 25 divided by 5 is 5, x, and then 12 minus 4 is 8. So this can be simplified to 5x to the 8th. The second one here, we have a little more complicated because we have two variables, but we can just go through the same way and do each piece individually. So divide coefficients, 60 divided by negative 30, and then for x, subtract the exponents, 4 minus 2, and then for y, we're also subtracting exponents. Remember, if there's no number for a power, it's an automatic 1. So that'll be 3 minus 1. So 60 divided by negative 30 is negative 2. This will be x to the 2nd and y to the 2nd. Now, the third example here, gets into what we're talking about in this section, and that's when we have two terms in the numerator of the fraction instead of just one. And what we're going to do for this is we're going to split it up into separate fractions. And so if you think about adding fractions where we get a common denominator and then add the top, this is essentially going backwards from that. So instead of combining into one fraction, I'm breaking it up into separate fractions. And so the denominator of each fraction is going to be the denominator 5x to the third. So each numerator is going to be written over the denominator 5x to the third. Now what I'm going to do is I'm going to simplify each of these separately. So for each one, I'm going to go through the steps that I went through above. So I'm going to do 10 divided by 5, which is 2. And then I'm going to have x, and then subtracting exponents, 8 minus 3 is 5. Then I'm going to have a plus sign, and then I just simplify the next one. So 15 divided by 5 is 3, and then x, 6 minus 3 is 3. So that'll be my answer. So next we're going to look at example 1. It says to divide 15x to the third minus 5x squared plus x plus 5 divided by 5x. So what I'm going to do first here is write this out so that instead of having the division symbol, I have the fraction bar for division. So it's going to be the same, whatever I have here for the top, the first number in the problem, and then divided by 5x. So 5x goes in the denominator. Now I'm going to do like I did in the last problem where I'm splitting it up so that each term from the top is written over the denominator separately. So they're each going to be written over 5x, and then the signs, I want to make sure that the sign in between is the sign that's there. So between 15x to the third and 5x squared, there's a minus sign. And then I'm going to have plus x over 5x, and then it's going to be plus 5 over 5x. Now I go through and just simplify each one separately. So different things are going to cancel from each of these, and that's okay. So start with 15 divided by 5, that's 3. Remember, there's an automatic 1 here. One thing that might be helpful is to just go through and write the ones in each time. So this is going to be x to the 3 minus 1, so that'll be x to the second. And I bring down the minus sign. Now, on my math lab, they're going to want you to enter things as most simplified as possible. So keep that in mind. Here, the 5s are going to cancel out. This is going to be x to the squared, or x to the second minus x to the first. 2 minus 1 is 1. So it's just x to the first or just x. So you're going to want to enter this as just x in order for my math lab to accept it. Then in the third term, these x's are going to cancel. Now here's a really common way that people make mistakes. This 5 is in the denominator, which means that it needs to stay in the denominator when I'm simplifying. It doesn't move around because I'm not doing an operation, I'm just simplifying. So 5 needs to stay in the denominator. There's nothing left in the numerator here, so what I need to put in the numerator is 1. So this is 1/5. It's not 5 because 5 needs to be in the denominator. So this is 1. 1 is what I put in the numerator here. And then similar for the last term, the 5s are going to cancel this time. That leaves me an x in the denominator. X needs to stay in the denominator, and then I put a 1 in the numerator. So this is the answer. So what you should do next is checkpoint problem number 2. Do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to look at example 2. It's pretty similar to example 1. The major difference is that now I have 2 variables. So I'm going to start by writing this out. And the denominator here is 4x to the third y squared. That's what I'm dividing by. So then I'm going to split it up. Obviously, if you're doing these problems, you can combine these steps together for a little bit less writing, but I'm gonna write it out so that it's clear. I have a minus sign in front of the 10x to the fourth, y to the third. And I have a plus sign in front of 12x squared y to the third. Okay, so now I just go through each fraction and simplify accordingly. So we start with 8 over 4, that simplifies to 2. X to the fourth over x to the third, 4 minus 3 is 1, so this is x to the first. And then y is going to be y to the 5 minus 2, 5 minus 2 is 3. So 2x y to the third. Remember, if this is x to the first, but you don't have to put that 1 there. Then I bring down the minus sign. Now 10 over 4, that doesn't simplify to a whole number, but I can simplify the fraction to 5 over 2. So if this happens, then what my math lab is going to want you to do is it's going to want you to simplify the fraction if possible. So just kind of be aware of that. So 10 over 4, I can divide them both by 2, and this simplifies to 5 over 2. Then I'm going to have x, the 4 minus 3, which is 1, y to the 3 minus 2, which is 1. Another way I could write this that should be acceptable for my math lab is to put the x and y on top of the fraction and then put 2 in the denominator. So I could enter it like that also, and that should be fine. Bring down the plus sign. 12 divided by 4 is 3. And then now here, this is a little bit different because for the x's, if I try and do 2 minus 3, it's negative 1. So what happens here, if I think about doing the cross out, write it out and cross out method, I have x squared on top, I have x to the third on the bottom. What's going to happen when they cancel out is that I'm going to be left with 1x on the bottom. So wherever the higher exponent is, that's where your leftover variables are going to be. So this x needs to be in the denominator. Now the y, I have 3 on top and 2 on the bottom, so the y is going to be on the top. So it's going to be 3y over x. So be careful with that. Wherever your exponent is highest, that's where your leftover variables are going to go. So this is my answer right here. So what you should do next is checkpoint problem number 2. Do this in your notes, check the answer, and then move on to the homework.